Hi, good morning to all, and I welcome you all, brilliant minds of my classes. And this is regarding about dual nature of radiation and matter. This is about the last part of this chapter, and we are going to unlock the next level of your potential on the dual nature of radiation and matter. We are going to see a significant ideologies of your debroglie hypothesis and some of the X-ray radiations, how the X-rays are produced. Based on this one, with the help of even a photoelectric effect that we have seen already. So now we are going to see this one a little more in-depth knowledge on dual nature and radiation. All you people are get ready to level up your skills and take your knowledge more deep on dual nature of radiation and matter. And all people, you just try to interact this session with the help of comments. We are going to use the online platform with the help of this one. You just pass your comments on the comment section so that I can discuss over with you on the comment section, as I am not able to talk with you physically, so that we can talk in online in digital manner. According to this, we are going to level up our skills with the help of the digital sessions. All people, please be welcome to the sessions on dual nature of radiation and matter. This is the last part over here. We are going to see this one in little more detail. Thank you all. We are going to see. Get ready for this. Problem here is the kinetic energy of particle is increased 16 times from its previous value. The magnitude of percentage changes in de Broglie wavelength. See again, de Broglie wavelength. What is that magnitude percentage changes? See this one old question paper problem. Now see here, in that case, de Broglie wavelength, already we know this one, lambda is equal to h divided by p. And even momentum value we can mention here, h divided by square root of 2m into kinetic energy. See from this one, see lambda 1 here is first one value is equal to h divided by square root of 2m k1. See, for the second one, they have increased the kinetic energy 16 times. So from here lambda 2 is equal to h divided by square root of 2m k2 here. K2 is equal to 16 times of k1. Now you just substitute in this case. So here is lambda 2 divided by lambda 1. Lambda 2 value here is, you just mentioned, h divided by square root of 2m k2 into this one here is square root of 2mk1 divided by h. So this one will be cancelled here, and even at square root of 2m also will be cancelled. From this one, square root of k1 divided by square root of k2. K2 value here is 16k1. So k1 divided by 16k1, again k1 will be cancelled here. From this one, 1 by 4. So lambda 2 divided by lambda 1 here is 1 divided by 4. See from this one, the percentage changes. So percentage changes of de Broglie wavelength. So percentage changes of de Broglie wavelength here is, see I just mentioned here, percentage changes in this case. So 1 divided by 4, this is what we got here, changes minus 1 into 100 percentage. See from this one, what you are having here is so that is minus 75 percentage. That means 75 percentage changes will be there. So answer in this case. So this one already we have seen, but there are some small difference. See here, a proton accelerated to a potential difference 100 volt. So that what happen here is, it will have a kinetic energy and has a de Broglie wavelength here is lambda naught. Lambda naught for the proton kinetic energy, lambda is equal to h divided by square root of 2mk. Hope you remember that one. Similar here, the de Broglie wavelength of alpha particle accelerated to 800 volt. First one is 100 volt. This is 800 volt. 100 volt here is lambda naught. The same one, de Broglie wavelength for 800 volt of alpha particle. This is proton. This is alpha particle. Similar concept. See this one I just mentioned. First one here in this case. See, p square divided by 2m, that one will be equal to the kinetic energy. Hope you remember k. So this kinetic energy, increasing kinetic energy, main reason here is the applied electron volt, ev, See, from this one, what I'm mentioning here is, see, P is equal to square root of 2m into QV or even EV. The charge according to what you have mentioned here is, if you mention this one, EV means you just mention as EV. Charge means you just mention as charge according to this one. See, from here similar. So from this one, what I'm going to mention here is lambda is equal to, lambda here is h by p. So h divided by square root of 2m e into b. See, this is for the first case, lambda 1 is equal to lambda naught. That's what they have given. Lambda naught will be equal to h divided by square root of 2m q into v. Similar here for lambda 2 also the same. From this one, lambda 1 divided by lambda 2. Similar one, instead of wasting the time, I just enter directly. HH will be cancelled here. Lambda 2 in this case, what you are having here is lambda 1 means here mass of proton will be there, charge of proton will be there, and the potential, that is V1, will be there. H will be the constant. So from here, here lambda 2 here is 2 into m2 q2 v2, and even the 2 also will be cancelled here, and whole divided by m1 q1 v1. Even the 2 will be cancelled here because the common term of h and 2 will be cancelled. So you just substitute the value from this one. See, this one here is a proton. First one is a helium. M2 here is 4 mass, and mass I just mentioned as m. For example, I just mentioned as m. Charge here is 2q of charge, and applied potential here in this case 800. And this one here is mass of proton here is m, charge here is q, and applied potential here is 100, and a whole power 1 by 2. See, from this one, what you are having here is, you just cancel here, 2 cipher will be cancelled there, and this one charge will be cancelled, m and m will be cancelled here. So so what you are going to have here is, and this one 2q 8818 will come here. So this is 2 is there, 4 is there, and 8 is there. So 18 will take it out. See, and lambda 1 here is lambda naught, and lambda 2 will be equal to 8. See, from this one, lambda 2 equal to lambda naught divided by 8. So answer in this case, this is little concept oriented. See, electron and a photon has a de Broglie wavelength. They have given 1.2 angstrom, and the ratio of their energies will be. See, first, what data they have given. One is about de Broglie wavelength for lambda e, wavelength of electron, and lambda b, wavelength of photon. So that one will be equal to 1.2 angstrom. See, next one, ratio of their energy. See, energy in this case, for example, lambda e, how you can mention here is h divided by square root of 2m into, this is energy in case of electron. See, from this one, energy of electron, how you can mention here is, see this one, h square divided by 4m lambda e square, right? Okay, now, so this one not a 4m, this is only 2m. Square means root will go. Next one, lambda of p. So that is E equal to h nu. You remember this one, for photon E equal to h nu equal to c by lambda. So h is c by lambda. From this one, lambda of photon is equal to what you are having here is h is c divided by, instead of lambda you are going to have a photon. See, from this one, photon, energy of photon here is what you are having, hc divided by lambda of p. Now what they are asking, ratio of their energy, that is energy of electron to the energy of photon here. Energy of electron h square divided by 2m lambda e square, and multiply with energy of photon here is lambda, uh, this one hc, right? So hc, this one, uh, energy of photon. See, this one here is yeah, lambda p, that is wavelength of photon divided by um, this one here is h into c. So this one lambda p and lambda e both are having a same wavelength. So what you are having, the final answer I just mentioned here, h square divided by 2m lambda e, and 1 h will be cancelled here. So h will be cancelled here. So I just erase this one. So h will be cancelled in this case. So into what you are having here is 1 divided by c. Now this one I just mentioned here. In that case, so what are the data is there? So E, that is energy of electron to energy of photon, here is this one Planck constant 6.6 into 10 power minus 34 here, and divided by 2 into mass of electron here is 9.11 into 10 power minus 31 kilogram here, and lambda e they have given, that is 1.2 into, and velocity of light here is 3 into 10 to the power 8. See from this one, see here this one I just mentioned as this is 6.2. This one you can cancel here, 10 power minus 31, 10 power minus this one here is what you are having, 10 power minus 3 is there, and this one 1.2 angstrom here. So 10 power minus 10 is there. So 6.2 into 10 power minus 3. So remaining thing whole divided by 2 into 9 I just mentioned as 18, only round off, I just round off that value. Then 1.2 is there into 3 into, you can cancel this one, for this one here is 10 power minus 2 is there. So this one you just cancel here. So what you are having, 10 power minus 1. See again you can cancel this one, this is 6.6, right? With the 3 if you cancel here, so what you are having here is 2.2. See 2.2, and this one 2.2 divided by 18 into 1.2 into 10. See this one 10 power minus 1 in denominator, that will become 10 here. So you just multiply this one, so multiply and cancel it here. So what you are going to have here is this value will become, see approximately if you cancel this one, so what you are going to have here is this will become 1.02 something will be there, and here is this is 10 time will come. So 10 into 10, 100 is there. So 1 is to 100. So in that case answer here is, next problem here is, if the momentum of a electron that is changed by p, that is changing momentum of electron is p, then the de Broglie wavelength associated with its change. So if momentum is changed to p, associated with the wavelength here is 0.5 percentage. So initial momentum is what? See now from this one what I'm going to mention here is, see what is the relationship between the wavelength and momentum here is lambda is equal to h by p, and this one from here p is equal to h divided by lambda. Now the changing from this equation I just mentioned here, the changing momentum here is del p and divided by p. P is about initial one. Similar like this is about lambda, that is 1 by lambda. So that one I just mentioned here, minus of del lambda divided by lambda. Suppose if p is equal to lambda, in this case how we can mention here is del p by p and del lambda by lambda. But here lambda, what's happening here is lambda is equal to 1 by lambda. So you have mentioning here as negative. See from this one, see I mentioned here for initial here is I just mentioned as p initial. The changing one they have given as p here. Similarly the changing wavelength here is 0.5, initially 0.5 percentage, that is 100. So 0.5 changes here is 100. From this one p initial will be equal to 100 in divided by 0.5 into what you are having here is p. So 0.5 here is, you can mention as 1 by 2 into p. So what you are having here is 200 p. So answer in this case here is 200 p. Problem here is the ratio of energies of moving particle and photon. Particle and photon ratio here is 1 is to 100, and their velocities are in the ratio of 1 is to 10. Then the ratio of de Broglie wavelength. See here what they are asking in this one. Try to understand these questions. They are asking about de Broglie wavelength ratio. See, de Broglie wavelength ratio of this one I just mentioned here, lambda of particles to the lambda of photon equal to what? That is the questions. But what are the things they have given here is lambda with the what relations we have to find out here is lambda with the relation of kinetic energy or with the relation of velocity. With this only we are going to find out. See, from this one already we know this one. What is the de Broglie wavelength? That one here is lambda is equal to h divided by p, where h is Planck constant, p is about momentum. See, from this one, what is the relationship between lambda and momentum? Momentum here is you can mention this one h divided by m into v. So here velocity you can make a ratio with the help of this one de Broglie wavelength you can find out later. See here, then why they have given about the energy also. So first we are going to find out the relationship between the kinetic energy and velocity. See, this one kinetic energy of particle or even a photon we can mention like 1 by 2 mv square. Now we know the relationship between kinetic energy and your velocity. See, from this one what I'm going to do here is, you hope you know about this one, kinetic energy k is equal to, you just multiply and divided by m. So this will become m square v square divided by m. So m and m will be cancelled here, so that the same of mv square will come. See, from this one I just mentioned here, m square v square is equal to 2m into k. Now this one, see here, from here mv, that one will be equal to square root of 2mk, or momentum p is equal to square root of 2mk. See, from this we can find out the relationship between momentum and the kinetic energy. We got a direct relationship, but here root is coming. So with the help of this formula we are going to substitute here. So lambda is equal to h divided by square root of 2mk. So simple concept. See, from the these two relation, one is about the velocity and the kinetic energy. See here, this is about velocity and kinetic energy. We have simplified, we got the formula is this one. See, with the help of this momentum which can relate both velocity and kinetic energy, with the help of momentum and de Broglie wavelength we can find out the ratio here. See, that one what I'm going to mention here is, see, I'm going to mention this one. Say for example, from here, see, I just mentioned in this case, from here lambda is inversely proportional to square root of kinetic energy. Simple concept. Lambda of what they asked here is lambda of particle, that one will be equal to 1 by square root of kinetic energy of particle. Similarly, lambda of photon, that one also inversely proportional to kinetic energy of photon. See, from this one lambda p divided by lambda of photon, that one will be equal to inversely related. So that what happened here is kinetic energy of photon to square root of kinetic energy of particle. See, already they have given kinetic energy of particle to photon. See, they have mentioned here kinetic energy of particle to photon, that is 1 is to 100. Here the same one, but here this is in reverse direction. So I just mentioned here kinetic energy of photon to particle here is 100 by 1. So what you are going to have here is square root of 100 by 1. See, that one you can mention as 10 square divided by 1 square. So what you are having here is 10 is to 1. So answer in this case, question here, this is a previous fold question problem. See, the energy of photon is equal to kinetic energy of photon. See here, this is proton, this is photon. See, this is particle here, this is light photon, right? The energy of photon is, see, energy of photon is E, and lambda 1 is the de Broglie wavelength of proton here. This is lambda 2 is the wavelength of photon. First thing, see, first try to understand the questions. First what I'm going to do here is two things. One is about particle, that is proton. Another one is about emitted light photon, right? See here photon, they have given the energy as E, and see here lambda 2 is the wavelength for photon, right? similar in this case of proton. Here I just mention as energy E, you just mention as E only, but in this case energy of proton, that is particle, that is kinetic energy. Here kinetic energy in this case, how you can mention here, E is equal to 1 by 2 m v square. This is kinetic energy, and the wavelength here is lambda 1. Now from this one, what they are asking in this case, lambda 1 divided by lambda 2 is equal to what? That's what they have asked here. See, lambda is about de Broglie wavelength. See, simple concept, lambda, how you can mention here, de Broglie wavelength here is lambda is equal to h by p. With this relations only, we are going to find out lambda 1 by lambda 2 is what. For in that case, what I'm going to mention here is for lambda 1 is nothing but this is for proton. Proton in this case, how you can mention here, h divided by p. P is about momentum, h is about Planck constant. See, for this, what I'm going to mention here is photon. The previous problem we have seen. See, from here, you just go for the previous problem steps. You can understand here. See, here, what I'm going to mention here is h divided by square root of 2m into E is about here kinetic energy. There we mentioned like a k. So that's what I difference between the previous problem and this problem here. Now from this one, see here, energy of this one, now energy of photon, not proton. Listen here, E is equal to h nu. Nu equal to c by lambda, h is e divided by lambda. This is for the first one, right? This is for the second one, lambda 2. See, from here how you can mention here, so lambda 2 is equal to hc divided by E here. So this is lambda 1, this is lambda 2. So what they are asking here, lambda 1 divided by lambda 2. Lambda 1, you got the value. What is that value? H divided by square root of 2me, and lambda 2 here is the same one, hc into square root of, not root, this is about E here, right? One h will be cancelled in this case. Now this one, this is constant here. See, from this one, what you can mention here is, so lambda 1 divided by lambda 2. So E is there, and this is a constant term. You just remove this one, you just mention as constant here. So constant will be cancelled. Say from this one, what you are having here is root E. So you can mention like E here is root E dot root E divided by root E. So this one E you can mention like this. See, for example, you can mention like a root 2 into root 2. What you can mention here is 2. Simple concept I have mentioned here. From this one, it has been cancelled here. So E power 1 by 2 or root E. So answer in this case. Next question. If electron are accelerated through a potential of volt V, the minimum wavelength of X-ray radiation. See the relationship between this one. Electron is accelerated and X-rays are produced. Now, when the electron will accelerate, when the X-rays will produce, so that whenever the electron is accelerated. See, in this case, see, for example, in case of a cathode and anode, for in case of X-ray production, you just see here. See, this is for in case of an anode here. Now, this one in case of a cathode. See, anode means a positive charge electrode and cathode is negative charge electrode. Now, in between this one, you have given the potential. That's what they are given as V. Now, this one, this is about capital V here. I just mentioned this one. See, from the potential which has been given, so that the fast moving electrons are interacted with the high atomic number target, that is photon. Once it interacted over here, so it emits X-rays. This is about X-ray production. Now this is X-ray photon which is having an energy E is equal to h nu. Now this is about the energy over here, and this one, see here, see this energy, how you are getting this energy, because of the applied potential. Now I just mentioned as E is equal to applied potentials to the electron here is E into V. See, this is equation number 2 and this is equation number 1. From equation number 1 and 2, see here, from equation number Simply you just mention here equation number 1 and 2. So what you are going to have E here is E into V, and this one here is H into nu. Nu here is, see, this is X-ray photon, and this is about applied energy. So here is Hc divided by lambda, and that one will be equal to E into V. See, this one what they have asked here is minimum, see here, minimum wavelength. See, just go through the questions. We have find the relationship between these two. See, we got the relationship between these two, but what they are asking here is minimum wavelength. See, from this one what I'm going to mention here is minimum wavelength. In that case, see here, lambda is equal to, already Hc is there, and E into V. So that's all. So answer in this case. The next problem here is the cutoff wavelength when a potential difference of 25 kilovolt is applied to an X-ray tube. See what they have mentioned in an X-ray tube, and what they are asking, cutoff wavelength. See, similar one previous we have seen. This is cathode. See here, and this side I just mentioned as anode. Anode is positive charge, cathode is negative charge. In between this one, you are going to give the potential difference. What they have given here is, see, this one I just mentioned here, that is 25 kilovolt. Now, see here, fast moving electrons are interacted on the target, so that from the target you are going to have X-ray. Right. Now this one, this electron, what they have mentioned here is electron cutoff wavelength. First, you just mentioned here, in that case, what you mean by cutoff wavelength. See this one. See, this is about, I just mentioned as, that is lambda minimum, that is the wavelength minimum, or even we can mention this one in case of a threshold wavelength. Even we can see in case of photoelectric effect, similar concept. See, at a particular wavelength of electron, it's interacted on the surface of the target that emits an X-ray photon from the target. If the wavelength, see, if the wavelength here is, if the wavelength here is maximum, which is larger than the cutoff wavelength, so that what happened, it's not enough to produce an X-rays. So that what happened, yes, minimum wavelength. See this one. So what is going to emit here is X-ray photon is going to emit. X-ray photon means definitely it will have an energy is equal to H nu. Already you know this one. What is nu? Nu here is frequency, that is Hc divided by lambda here. See, from this one already we have mentioned, that is about cutoff wavelength, so you just mention as lambda minimum. See, from this one, lambda minimum will be equal to Hc divided by E. See, that is in joules. So energy is in joules, but they are given in electron volt, so that you just need to substitute here 6.64 Planck constant, and velocity apply 3 to 10 to the power 8, and even you can mention this one electron volt equal to 1.6 into 10 power minus 19 joule here. See, from this one, 1 joule equal to 1 divided by, see, all this value if you substitute here, you always remember this one, Hc divided by E. That how you can mention here is 12,400 divided by, this one is in electron volt. Volt here is about a potential difference. So you can mention this one. This is in, so even this one also in electron volt, and here energy is in electron volt. So that answer will be in angstrom. Now you can mention here lambda minimum or even lambda cutoff. Both are same here. So to understand if this one, I mentioned both, lambda cutoff or lambda minimum will be equal to 12,000. You always remember this value, 12,400, which is in electron volt, divided by V. That's all value here. See this one, 12,400. What they have given the value, that is E value here is 25 kilovolt. That is 25 into 10 power 3. So you just cancel this one with this 2 cipher, and this 3 cipher will be cancelled over here. From this one, what you are going to have here is, say, I just mentioned as 12.4 divided by 25. So from this one, if you cancel here, what you are going to have here is, this is an angstrom, already I have mentioned here. So this one also angstrom here. So that 0.5 So this one here is 124, 4 times is 100. So approximately 49 angstrom. So answer in this case, what they have given here is the energy of X-ray photon. So E value they have given 4 kilo electron volt. What they are asking, its frequency is nearly. Now simple concept here. So they have given the energy in kilo electron volt. See here. So till now I used to mention here energy in this case. Suppose if you are mentioning this one, E is equal to h nu. Now remember here, E is equal to h nu means here energy what you are going to have, photon energy values is in joule. Always remember this one, right? They haven't mentioned this one kilo electron volt. See here, but what they have given here is energy is in kilo electron volt. So that, see here, what I'm going to mention here is they are asking about frequency from this one, nu is equal to E divided by H. That's all. See this one, kilo electron volt. What they have given here is kilo electron volt, but actually the values it should be. So directly you can mention here 4. 4 kilo means 4 at 4000. That's all, simple values over. But electron volt they have mentioned here. So that what we are going to do here is frequency nu is equal to, that is 4 into 10 power 3, and the electron volt it is mentioned as 1.6 into 10 to the power of minus 19. You always remember this one, electron, this is charge, right? And divided by Planck constant 6.624 into 10 power minus 34. Now HC by lambda, like that if they are mentioned here is the previous problem, you can go through on this one. From here you just multiply this one and reduce that value from this one. What you are going to have now, you just cancel here. See this one from here, see kilo means, see this one from here I just mentioned this one, from this two first you just cancel here. So 19 means around minus this one 10 to the power of 20, 24, 5, around 15 will be there, right? See from this one, if it is go over here, 4 into 10 to the power 3 is there, and even 1.6 is there, and divided by 16 into 4, 64. This is approximately 64. If you mention this one 64 here is, so what you are going to have 10 to the power of 18. Already this 15 is there. From numerator, that is plus 15 plus 15 plus 3 here is 8. See from these two you can cancel here. So what you are going to have here is, see this is 15. I'm sorry, this one here is 15 is there. 15 plus 3, 18 is there. So total one is 10 to the power 18. Frequency means unit here is hertz. So answer in this case 10 to the power of 18 hertz. In this case again, what one more questions also they used to ask this one, that is about wavelength of X-rays is in the order of. So X-ray wavelength order, what will be in the order here is, it is always the X-ray order. So this is the direct option questions here. X-ray order is in 10 to the power minus 10. That means we call it as angstrom. ANG, not Armstrong. This is angstrom. So answer in this one 10 to the power 10. Always remember this one. The next problem, see here, the momentum of photon of energy 1 mega electron volt will approximately be. That's what they are asking. See, we may have a doubt what they are asking, whether they are asking about energy or they are asking about momentum. See, you just how have to read. See, this is on little, see here, from here to here, this line, you just avoid reading this line, then you just read. See here, the moment of, see this one I just mentioned here, see the momentum of photon. See, you can understand here, the momentum of photon will be. So what they are asking, momentum they are asking. Say from this one you can mention here, say momentum, what's the formula here, P is equal to m into v. So this is about the formula for momentum. See, and unit you just mentioned here, mass can be measured in kilogram, velocity can be measured in meter per second. See from this one, in one way you can mention here kilogram per meter per second, kilogram meter per second, all units are in this way. So you can understand this one. What they are asking here is they are asking about momentum, but what they are given here is energy. See, photon they are given already. We know the formula for energy of photon. E is equal to h nu. Say from here, mu is equal to c by lambda, hc divided by lambda. Now we are going to find out the relationship between the energy and the photon. See, from this one, according to debroglie wavelength, lambda is equal to h divided by b. From this one, I just mentioned here, p is equal to h by lambda. See, from this case, see here, h by lambda. See this one, h by lambda. For that, what you are going to mention here, p. So E is equal to p into c. See, from this one, momentum p is equal to E divided by c. Now you just substitute the value here. P is equal to E value, what they have given, 1 mega electron volt, 1 into 10 power 6, that is mega electron volt here is 1.6 into 10 to the power minus 19 whole divided by, and C value here is 3 into 10 to the power 8 meter per second. See, from this one, you just cancel here. See, for example, this is 15 means 5 times, 1.5 means 0.5 times. Now see, from this one, 0.5 into, say, from here, this one and this one, if you cancel this one, this is 10 to the power minus 13 and whole divided by 10 to the power 8. Say, from this one you can mention here 0.5 into, so 13, if you mention this one, if it is go over here, so 13 plus 8, what you are going to have, 13, this one here is 10 power minus 8. See, from this one, if you cancel here is, what you are going to have, 21. See, this one 10 power minus 21, right? Say, from this one again, 5 into, say, 10 power minus 22. So unit here is kilogram meter per second. So answer in this case, we came here coming to the end of the sessions, and thank you all for your patient listening the sessions over here. And if you are having any doubt, please you put your doubts on the comment section, so that I can interact with you people on this one in an online platform. In case of in a classroom, we can discuss directly, but in online platform, this is the only way we can discuss over here. If you are having any doubt, put your questions on the comment section. I try to make, definitely I try to make shorts, and I will upload the shorts also. I will pass the link, and you people, you just subscribe the channel, so that shorts also immediately updated over here. The only possible thing is, if you put any comments on the comment section, so that we can interact over here. If you are having any doubt, or even if you are not able to understand the classes, you just mention that one, in which way I am missing that one, so that even I can learn over here how fluently I can explain the problem in a short way. That is the better understanding for both of us. Pause the comments and subscribe the channel, so that all the updates will be reached on time. Thank you all, and thank you once again for your patient listening on the subject. You people, physics is easiest one, but you need to practice it well, and you just give me your doubts on the comment section. Thank you.